Thank you everyone for joining us today for this Tech Talk webinar, part of our monthly series of webinars that we do here at Oasis Sales and TriLogic. Today's topic is going to be proper DFMA, DFA analysis. So just a quick overview. Oasis Sales and TriLogic are sponsoring this webinar. Oasis Sales is your authorized reseller for Intergraphics in the Midwest. Please contact Oasis Sales. More information on the topic that we're talking about today, or any other tools from Intergraphics or Siemens. And then TriLogic is our other sponsor. They're located on the East Coast. Please contact TriLogic for more information on Intergraphic or Siemens products. So again, TriLogic is on the East Coast. Midwest is covered by Oasis Sales. On our YouTube channel, and here's the web address. You can go out there and review any of the webinars that we've done in the past. You might find something that interests you. If you're not familiar with all the webinars that we've done to date, it's about 2 years worth. We continue to do them each month. The next webinar will be Did You Know webinar on design rules, routing automation, and using that to your advantage for shortening your design cycles. That's going to be next Thursday, same time. Products being covered will be mainly PADS Classics and PADS Professional. Again, we're available for you to call us anytime if you need help or if you have additional questions regarding the topic that I'm talking about today, or any other thing, any other tools related to Intergraphics or Siemens. If you have any questions, there should be a little go-to control panel that popped up when you logged in. That window will have a chat function on it. Feel free to type a message in to me, and I will do my best to answer that either while I'm going through the webinar, or the main Q&A session will be at the end. All right, well, let's go ahead and get started. So again, our webinar today is on proper DFM, DFA analysis and what it's all about. I've been doing this in all the webinars that I've personally been doing, covering what is the digital twin way of thinking when you're designing a product. Many of the tools that we've gone over have hit on pieces of this, and what I'm covering today will also continue to distill the importance of what is known as the digital twin. Siemens is leading that market with the Intergraphic acquisition and many other acquisitions that they've made, plus their own tools with production planning, data management, the electrical engineering side of it, along with the mechanical engineering side of it as well. So if you're not aware of the digital twin, do research it on the internet. It is a philosophy that some of us have been using to some extent. You know, many of us have been doing analog simulation, signal integrity analysis. Some of them you have probably used the Balor tool for doing manufacturing verification before you go to physical manufacturing. So let's move on and go ahead and get started here. So what is DFM and DFA? Well, DFM stands for Design for Manufacturability. Hopefully, if you're a PCB designer, you've understood that. And DFA stands for Design for Assembly. Again, hopefully, if you've done any of PCB design, you're doing that. So why do I need this process in my design flow? Well, the first thing is it will considerably help with first pass success in taking your designs to manufacturing. It'll allow you to produce higher quality, and also more than likely produce less revisions. This has all been proven. How do I implement a proper DFMA, DFA process in my flow? Well, let's go ahead and take a look at what's being done today. So this first set of graphics we're going to look at here is what's happening today. You build library parts, you do your front end design, you do your placement of your PCB, you do your routing, and then you move on to final review. Of course, through this process, you are doing basic design rule checking that we all put in the PCB to help, prevent copper violations or copper objects overlapping other copper objects that would obviously make the design not work. But the one thing we don't do is we don't go through the extent of, and no CAD tool really has the capability of doing it, go through the extent of doing true manufacturing and assembly verification. And in that process, doing that, we rely on our fabricators or contract manufacturers to do this. Obviously, fabrication houses do it, but they do it just to the extent of, can this thing be built but not to the extent of is it going to be a quality end product for you to deal with long term and for your customers. And on the contract manufacturing side, they usually charge for this service of doing verification. So if you're using a contract manufacturer to do DFA, more than likely you are being charged for that process. And the kind of thing that a lot of CMs don't tell you is a lot of times they won't identify everything that's wrong with that board. They'll do just enough to get a build through. And the next time you send the design through, they might clear up a few more things. They're looking out for themselves in the process of doing DFA analysis. They're not looking out for the customer. What can happen is they'll identify issues. If those issues will prevent the board from being built, then you have to go back into your design phase and, you know, fix those problems, run it through your own internal review again, send it off, and then they'll verify it again. And possibly that could cost a little bit more money as well. But the big thing that you're probably noticing here is this is a time delay, okay? So if you're under a crunch to get to meet a schedule and you have to go through this process, it's gonna more than likely cause a delay and won't allow you to meet your schedules. So what should this process be? Well, let's take a look at what the process should be in a very fluid and dynamic DFA analysis. So even at library creation, we can use DFM, DFA tools to validate our footprint. So when we get to the point of placement and assembly review with the contractor, you're never going to run into issues because you've already validated that footprint against your or your contract manufacturer's DFA rules, so that you don't have to go back and fix footprint related items later on. And we'll talk about some of that here in a minute. So then we move on to obviously the front end design phase as normal. We go to PCB placement, and then once again, we can bring in the validation tools for fabrication and assembly and validate that design before we move on to the next step. So we're preventing, if something is found later on, even with a physical review where you have people in a meeting, you know, physically looking at the board graphically, they find a problem related to manufacturing, you then have to fix a lot of the critical placement items that you've done, which affects routing, and therefore, again, slows down the design process. But if you continue through your design process using the Valor NPI tool or some other manufacturing validation tool, you'll fix those problems before they ever occur. And moving on, and when you move on to the next phase, you won't have to rip up anything that you've done in order to fix the problems that are found later on. So again, even at the routing phase, you can, again, verify the design based on that set of rules. So that's another thing I should note is as you go through this process, you don't have to use all of the design rules that these manufacturing tools are capable of checking your design for. You can segregate the designs into different groups and categories based on my process that I'm using for the phase of the design that I'm at, and it makes the process of doing the DRCs much faster. We'll talk about, again, that a little bit more here in detail when I show a quick demo of the tool. So then we move on to final verification after verifying and routing. So our final review at this point in time, this is where most companies usually spend a lot of time in meetings, reviewing the board at this phase with manufacturing, other engineers. If issues are found, then obviously you have to go back and fix it. But because you've been doing your verification all along, this design review phase is going to happen much faster, and more than likely you're not going to find any problems. Therefore, moving right on into being sent out to be built. And again, the advantage here is you can tell your contract manufacturer you don't need them to do verification your designs, therefore saving you time and money on their end. They can just pull the data in, prep it up for assembly and fabrication, and move on. So if we compare these design flows to design chains, this is what most people are doing today down here at the bottom, just because they either don't have DFM tools internally or they've never really thought about it. And this is what a streamlined process would be at the top, is you've implemented a design for manufacturing and assembly tool in-house instead of relying on an outside supplier, and you can verify different pieces of your design as the process is progressing on to producing the final outputs. Now, if for some reason you're producing low volume designs, you're only doing a couple a year, sometimes it doesn't seem justifiable to spend the money on a DFM tool. You can at least partner with someone that has a DFM tool that can verify your designs, again, as the phases continue along. So don't wait until the end to do this. You can get your supplier involved early, so even during the placement, critical routing phases, you can have them verify your design. Yes, there's going to be a little bit of time delay in there, but it's better than waiting till the end and finding those issues and then having to go back and rip up a completely routed board, which is definitely more time consuming. All right. So this design flow looks pretty good, but I think I understand the DFM side of stuff, but how does the DFA side of things work? Well, as PCB designers, we all understand the fabrication side of it. Many of us don't understand the assembly side. It works actually very much like the fabrication side. The big difference is you have the ability with an assembly verification tool to go in and validate your solder joint and pad geometry to make sure you're going to get good solder joints, reliable solder joints during the assembly process. This is something that very few DFM tools have the capability of doing out there, and really no PCB design tool has this function. So you can set up design rules that say, how much toe fillet do I want, how much heel, how much contact area there is, side fillets, in order to produce a good quality solder joint, plus being able to verify, did I put the pins all in the right place on the part? Is the pin shifted or not in any direction? You're basically modeling up the design to confirm that your solder joints are going to be acceptable in the assembly process. This is probably the #1 thing that your contract manufacturer is also looking for when they do validation on your designs for you and they charge you for it. All right, another value that a DFM tool can bring to the table is if you have multiple packages. A lot of times when we pick apart, we're not, especially with passive components, popcorn parts, the supplier can end up choosing a manufacturer for an item. Well, not every manufacturer makes package the exact same size as another, so being able to validate your AVL components against the footprint that you're using, either again at the library phase or during placement, is extremely valuable, knowing that when this design goes out and it's going to be built for the next 5 years without modifications, that at some point different manufacturers' packages are going to be placed on that board. You know you're not going to have any solderability issues related to those different package sizes. So again, a extremely valuable feature in doing DFM in-house beforehand. So of the DRC checks that come in most DFM tools like Balor and PI, about 40% of the design rules require a part model to do validation. So the things that I just talked about, being able to check those solder joints, require a model. Well, that just, you're probably saying, well, now I got to deal with more library stuff. Like you're already dealing with schematic and PCB libraries and models for simulation. In order to validate something, you have to have a model. Well, luckily, at least with the Mentor tool flow, we do offer a subscription to a library with 35 million plus manufacturers' part numbers with models assigned to them that you can take advantage of with that subscription. They also offer a service where you can build parts I shouldn't say you can, they can build parts for you on different turn times. You send them off the information, they'll turn it around for you, put it in the master library. So this number continues to grow as people continue to have parts built for their purpose. And then lastly, obviously, you can build your own parts. Just like any other CAD tool, having the ability to go in and build those very unique parts that your company is either manufacturing or they're just super unique in the industry for your requirements. You do have that capability to build those and put them in your own library. By the way, when data is downloaded, it is stored locally, so you don't always have to go out and retrieve that information. So the question may be asked, I'm still not convinced what the additional benefits of that or that DFMA or bringing a tool like this in-house is something that I can really grab onto. So what are the additional benefits that our company would see when implementing a DFMA strategy? So here's just a couple things that would be advantageous. You have complete control over the design process. You're not relying on a contract manufacturer to deal with it anymore. Can ensure that you're producing high quality solder joints for designs that are going to be in stringent environments, either thermally or shock and vibration. You can play around with your footprint control. Cost, you can control the cost better for your parts and just the design process in general. You're not having to do as many design spins possibly related, if you have issues related to DFM, DFA in the past. Time to market, you're going to be able to definitely, when you say this is the schedule of what it's going to be, you'll definitely be able to hit those marks because your fabricator and assembly contract manufacturers are not going to hold you up with time delays in doing verification for you, or if they find problems, you having to go back and fix it. All of this can lead up to tens to hundreds of $1,000s in savings per year. It's been documented numerous times with customers that have brought DFMA in-house and how much money they end up saving just in the first year alone in implementing a process like this. All right, so let's take a closer look at the Valor MPI tool, the #1 manufacturing DRC tool in the industry. Mentor owns about 87 to 85% of the market for this class of tool. It's used by about every fabricator in the world almost, and even every major contract manufacturer that you're going to be working with has Valor for doing verifications just for these purposes. And the main reason of this being is they offer the most feature-rich capability from a tools perspective of analyzing designs of any form, shape, or function, from flex to high-density interconnect verification. No other tool offers the DRC functionality of Valor MPI. So let me go ahead and I'll close this out real quick. And we'll just do a quick demo here of what Valor MPI is. So Valor is not a tool that can only be used with Mentor products, even though we own the product. It does have great integration with Expedition, PADS Professional, but by no means, if you're a Cadence user, Altium user, Eagle, whatever it may be, that doesn't mean you can't use this product. Valor uses a industry standard database. In fact, it is the Valor database that became an industry standard. Even IPC based their new standard somewhat off of the Valor specification. So what I can do is if I output ODB++ data from my CAD tool, which every major CAD tool in the industry can output ODB++ data, I can open that data directly in Valor. We do have the capability of bringing in actual Gerber data, of course. We also have some EDA interfaces for bringing in native CAD data as well. But how do I go ahead and get started here? So I'm going to just click the open button and I'm going to go out and find a design where I've output Gerber data for it. So let's go to my demos here and I'll go into this design. And this is a folder structure basically for ODB++, but you can open the standard TGZ file that most tools produce for ODB++. Go ahead and accept that directory. This will then bring that data into the Valor NPI tool. Now at this point in time, I can go through and I can manually continue to look at this data. Like I can go into the device or go into the design. I can open the design in the manufacturing risk assessment application. This one's actually been run through the DFM process already, so you can see it's found there's a bunch of violations in here, and I can go ahead and start looking at that data again. Or if I'm starting a new design from scratch, this is how simple it is to really do DFM analysis using this application. I can run this wizard. This will basically set up all the options for me beforehand, so all I have to do is answer a couple questions, like where do I want this data to be created? Let's see, I want it to go into my demos folder, and then what do I want this to be called? Call it webinar. Then I'll go grab my DFM data, accept that directory. Everything else is already set up for me, so at this point I just hit next. There's several options here that, again, are already defined. I don't need to do anything. Just hit next, next. I'm going to be bringing in a BOM, so I need to go grab that BOM. The best way to produce this is just in an Excel format. Hit next. Already got rules set up. Hit next, and now it's going off and starting the validation process for me. It'll stop at several different phases because I've told it that I want to review the data. You can actually set up the wizard to where you literally won't see anything happen until the MRA tool comes up for you to review the violations that it's found. But I'm choosing to investigate different phases of the validation process. So this is letting me see the stack up. If I have blind and buried vias, I can see all the via stacks in here, make sure they look appropriate. If not, I might have to go back and fix something in my design. So hit continue. This is just letting me see the board outline. If I want, I can turn layers on and off at this point in time so I can see the different layers in the board. Make sure, again, I just visually click, don't see anything erroneous. Move on to the next phase. I can see all of my drill data. And here I can just visually validate that. Continue on to the next phase. This is where it's bringing in the bill of materials for me. I've already told it I had a template set up to match my BOM, so I really don't have to do anything. You can see it matched 348 components there. I can look through that real quick, but I'll just hit continue. That will bring in the BOM data into the tool, and that's the last phase before it actually goes off and does its validation, which you can see there. It just did all of the validation. That's going to merge in my assembly information. So this is where it's going out, and it's going to use that BOM manufacturing information, going to go out to the VPL server, the Valor parts library. If we have a subscription for it, it's going to grab models, download them into my library, place them on the board, and then do its DFA checks against the models on the design. Other things that it's looking for in the assembly space, it's looking for component to component based on different package types and sides. There's a whole matrix of rules you can set up, and how when one part rotates up against another part, how close they can be to each other, one package classification to another, how close they can be to each other, how close you can be to test points. There's DFT analysis capability in Balor as well. There's high speed. There's some basic high speed stuff that it can look at. You can, if you're doing HDI design or flex design, you can add on DRC functionality to validate those designs as well. If you're doing panelization in Balor, Mentor has actually spent quite a bit of effort lately in making the panelization process much easier within Balor. So you can do assembly panels and then full up panelization if your company requires doing that part of the design instead of farming it out. You can do that inside here of Valor as well. Right now, it's continuing to go off and do design verification on this board. This is a pretty good sized board, so I would expect it to take a little bit. I think it takes about 5 to 8 minutes here to validate this design. It's getting close to being done. Let's see, this would be a good time for me to go check to see if someone's asked any questions here. I've got a couple, looks like. How does one output ODB from Eagle? Personally, I've never used Eagle, so I don't know exactly what the process is for outputting ODB from that application. But like I said, Balor does allow you to import Gerber data as well, but it would be very advantageous if you could figure out how to use or output ODB++ data from Balor. Let's see. So this question is related. So if I have a circuit board that requires 8 gigabit speed, is there a formula that will show for a solder joint or gull wing buildup in the order of the order that the drive will not come off the board if mentioned the G-shake? That's what I asked. So there's nothing built into the tool that's going to tell you if during shock and vibration if a solder joint is going to be sufficient or not. You know, there's obviously other simulation tools out there to do that, where you can simulate shock and vibration prior to actually getting a board fabricated. But through the process of using a tool like that or having a consultant service, you know, figure out based on your solder joints and the materials you're using, you could determine optimal pin or pad geometry and then enter those as rules in Balor, so that every other design you check from that point forward, you would be able to have a good analysis of your design. Now, I think I just answered that second question you asked there, Dale. So can VPL compare the Mentor VPL model to a company model in our library? Good question. I'm not 100% sure if that can be. I don't believe so. You would have to run a test in a design where you place a model that you created in your library and one that Mentor created that you downloaded into your library onto the design and do a validation between the two. If you do find models from Mentor that don't seem to be right for some reason, you know, they have a mechanism for reporting that this model is incorrect and they will go fix it. So if you are seeing models that don't look right or don't match the specification for a particular manufacturer's part number, by all means, please contact Mentor Valor Group and have them fix those parts. All right, so the analysis has now been completed. What we have here in the GUI is a histogram real quick that shows us the different major categories of design rules. Where we have failures in red, yellow are things that are on the edge, may need depth to see if there's any issues. But if I click on any one of these categories, obviously up here at the top are the same rows, I will see the listing of all the major category or groups within that section. So etch is going to be all of your copper related items. All right. So if I look at a signal layer on the outer layer and I look at trace width information, once I click on one of those violations, I can see a histogram of where it falls within certain buckets, and I can change the resolution of that bucket. And then I can choose one of those histogram bars and use the navigation features up here to navigate in the design and see where that violation is. So this violation appears to be a trace in the keep out area, which seems odd, but let's see, let's not look at one of those. Let's see, here's a stub trace. So this has found a trace here that must have been left behind from a rework or something that we did where we left a via and a trace there that doesn't need to be there. Trace width is too narrow for a pad, or the pad's too narrow for the trace. So these can lead to solderability issues when the part or the design is going through reflow if you have too much copper coming off of a pin, it can make that component tombstone, especially passive components can have that problem. Because one of the things that you'll really start to learn when you're starting to do DFA analysis internally, what all the little things are that can cause possible yield hits during the assembly process. Short sliver, so we kind of everyone knows what acid traps are. That's what it's caught in this case here. So that looks like a violation in itself, just looking at it there. But obviously this design, we intentionally put some errors in there, but many designs that people create out there will have these types of violations. Fabricators will usually go fix these on the fly and never even tell you. Some fabricators will give you back a report saying, hey, we had to fix these items. But if you specifically specified in your drawing that you're not allowed to modify data, then that's going to hold up your design from fabrication if you're not validating these types of small violations or design issues beforehand. So Valor does try to give you help during the whole process of validating these errors. We can turn on the information button here, and each error that I click on, it will give me a little bit more detailed information about what that violation is looking for and why it might be a problem. So again, you can use this as a learning tool alone in learning about fabrication and assembly validation, just like you can with hyperlinks or signal integrity tools. They can be educational along with being able to actually do its job. All right. So I'm not going to go through all of these. Obviously, there's a lot of violations in this design, but again, the design rule set I'm using may not be 100% to this the data set that I'm using. So as you go through and develop your own rules, you'll see less and less violations as the design process continue on through the years. But just being able to validate it, just to have a double check, is always a good sanity. Now I want to explain a little bit about how the design rule function works with the tool. So previously to 10.0 of this version of this tool, you went into what was called an ERF manager, Engineering Rules File Manager, and this is where you defined all of your design rules. Okay, so there's major categories, and then in each one of these subcategories, you would set up your design rules using variables and constants and ranges. Okay, the Valor team has recently came up with a new scheme for doing design rules, and it's called the MRA Revolution. Is a new methodology for doing design rules. It's going to make it a lot easier for those that don't have extensive experience using Valor to create and define the rules that are used by the tool. Okay, so if I come in here to the Tools menu, Analysis Definition Manager, I'll just do a very quick rundown of how some of the design rule methodology is changing with the tool. So what they do is we're now defining what's called the classification, which would be like a supplier or a technology type of printed circuit board. So in this case, this would be like a 3 mil space and trace type design. And then you create what are called factors. Factors are major design rule categories within the tool, and then you can set parameters on those that you can then define design rules against. Okay, so let's go back and look at like this classification set. So we've created a group called Standard, Advanced, and Complex. And each one of those, we're using factors to determine if a board has greater than 8 mil trace in space, it's going to be standard. If the board is less than 8 mil but greater than 4, it's going to be advanced. And if it's greater than 3 but less than 4, it's going to be considered a complex design. And then I can base my constraints off of that. So if I come in here and look at some of my copper spacings, we'll see for each classification set that I've created, inner, outer layer, advanced, complex, and standard, I can specify a different set of rules. So this just makes the process of defining the rules much more simple for the average person understand. Plus, it eliminates a process that Balor used to have for classifying the design anyway. So you could create, and through that ERF manager I showed, you could create multiple different sets of rules for different classifications, and you had to pick the right one in order to run it against that design. Now the tool's more intelligent, and based on this less than, greater than, or a range type selection, it will determine itself what category it should fall into. So this is just a quick introduction of some of the new rule capability that's in Balor that will assist with new people coming on board in setting up and understanding the design rule process. Let's see, I think I have a couple other questions here. What version of Balor NPI are you using? I'm currently running version 10.2. It's the latest release. The MRA Revolution functionality was added in 10.0. So if you're seeing some differences in the GUI here than if you're using Balor today, that could be why. And then for our Expedition users out there, I want to just give a quick rundown if you're not aware of it. Hopefully you are. That if you're an Expedition user and you have Balor, or if you're an Expedition user and you're looking at implementing Balor, you can run the tool from Expedition itself. Okay. So all I need to do is when I go into ODB++ output, I need to create a configuration called NPI DFM. This is what the automation process will use. So you set up all your ODB+ outputs, and it will use that for generating your outputs. And then you go to Analysis, Balor NPI DFF, and it will basically generate the ODB data in the background. It will go off and analyze your design for you, and then it will bring in all the violations that I had showed in the MRA right into Expedition Review Hazard or Hazard Explorer, so that you can now find those violations much faster than going in MRA and having to try to synchronize across back into Expedition. By the way, for those customers out there that are using Cadence, if I have anyone on the line that's using Cadence, Mentor has automation written for Cadence to where you can do something very similar to this. There's a toolbar functions that are added into Cadence. You can click on it, it will automate the process of creating the design, and then you can cross-probe back into Allegro for doing your design rule analysis and fixing any violations that are found. So it's continuing on doing its process. I've actually ran it in this design before, so I'm going to go ahead and jump into what will happen. Basically, in the Hazard Explorer, you'll get a Balor NPI tab here, and this will show you, will come up with the, oh, there it just finished. So it came back and tells us that it's completed the analysis, and I can go ahead and hit the refresh button here, and it will reload back in or load in any new violations that were found in my design. But now I can click on one of the categories, red or yellow, and it will show me all the violations that it found in the design. Now, if this looks a little daunting, you can just turn on the filter function here, and then I can use filtering capability to say, okay, all I really care about is the CPU short slivers. And I found that one, and then I can click on that and have it navigate into the workspace for me, and show the DRC violations, and then I can go in and fix that problem. Then I can go search for more violations right within Expedition instead of having to worry about using that MRA interface. I can use something that's familiar to me for finding the violations. I can see what the measurements are and what the actual, or what the rule is, and what the actual dimension is, and in order to determine if I need to fix that or not. Okay, you can flag things as being acceptable, like just like any other design rule in Expedition, so that the next time around it will not show that, or you can filter out your accepted DFM violations. So that's a quick introduction to DFM, DFA, the process that can be added into your design flow. Just to do a quick recap, So design for manufacturing and assembly is an extremely important step in electronic product design. For those companies, again, not doing it, hopefully you can see the value and what I showed today of being able to validate your design for things that your PCB tool just doesn't have the capability of checking. And if you know that you've gone to fabrication and assembly, you've had designs come back or put on hold because of issues, then Valor MPI could definitely be a solution for avoiding those delays in your manufacturing process. Manufacturing verification can start early in the phase. A lot of people still, even though they had Valor, would only use it at the end of the design process. You can actually start using this when you create your footprints at the very beginning. That just eliminates any future issues that you could run into or things you have to worry about later on when doing validation in the design. You can focus on more point things like component to component data and routing information. You don't have to worry about doing your footprint verification because your library has already been validated. So DFMA rules can be checked continuously during the design phase. I showed that in the flow chart that I put out, that don't wait till the end to get these types of DRCs and violations found and captured, because then you have to go back and spend a tremendous amount of time fixing them. Perform the various checks takes very little time, as I showed in using Expedition or using the Valor tool itself. Going through the process wizard takes a few minutes to analyze a design. So it's not a painstaking process to put this into a flow, and it's not like it's going to take a lot of time to perform. If time and money are important to your company, then implementing a DFMA in-house is something that should definitely be start to be investigated on. Let's go see if I have any other questions here real quick. So another one that came up, I kind of mentioned this one earlier, can you cross-probe with most CAD tools? Obviously Expedition, yes, and Cadence, yes as well. Other tools like Altium, Pads Layout, Eagle, some of those types of products, no, you're not going to be able to do that. But you can at least, you can still use the two tools side by side and help you find the locations of where those violations are to fix them. So it's better to do something than nothing. Can I import native CAD files? Yes, Valor does have the capability to import, say, native Altium files, Pads files, BoardStation data into the tool. Is it difficult to set up rules? It's what do you classify as difficult, I guess. It is basically a DRC tool, so the rules are what really make the tool do its job. So yeah, obviously there's a lot of them. I think on the assembly side, Valor has about almost 800 design rules that could be implemented, and then on the fabrication side, there's another 800 design rules. And if you throw in Flex and HDI, you're looking at probably another 150 or so. Now, are all those going to be used by every company? No, by no means. You need to pick out the ones that you feel matter the most to your design process that you're using, and then define those rules. Another thing that's kind of cool about Valor, since most of your fabricators out there and your CMs do use the Valor tool, you can always request from them to share their design rules. It's been my experience that fabricators are usually fairly open to that. They'll send you the design rules for their Valor tool or their version of it, and then you can import those into Valor MPI and use those moving forward. So that would alleviate a lot of the design rule setup process. CMs are usually a little bit tighter on that. They consider it IP because they're making money off of it. Fabricators aren't. It's just part of a process. That's kind of a standard thing. So I'm not seeing any other questions here, so we're going to go ahead and wrap it up. I want to thank everyone for joining this tech talk on DFM, DFA. Hopefully this was helpful and you got some good information out of this. Again, this has been recorded, so we'll put it up on our YouTube channel for you to pass around or watch at a later date and time, or let some of your colleagues know. Well, thank you everyone for joining us today.